let's do one more example of solving using substitutions on a 3x3 system of equations. I've kind of summarized our steps for solving over there on the right. So if you recall, the first thing we want to do is isolate a single variable in one equation. Then we're going to substitute that expression in for the variable in a second equation and isolate a second variable. Then we're going to substitute that into our third equation where we will be able to start solving for our variables. So in looking at these equations that we have, I noticed two equations that are candidates for isolation. I tend to look for equations that have variables with no coefficient. So if we look at equation 2, we see that z is just a plain plus z, no coefficient. So that would be a candidate for isolation. But I also noticed in equation 3, we have a negative x. So yes, it has a coefficient of -1, but that's really easy to get rid of. We don't run the risk of having fractions or anything like that. And that's actually the equation that I'm going to choose to use because I noticed that there's only one other variable in it. So it only has an x and a z. So I'm going to choose to isolate my x in this third equation. So I'm going to subtract 5z from both sides. So we get x equals -5z minus 15. Oops, sorry, negative x. And then we're going to have to divide by -1, which just changes the signs on both sides. So our equation says x equals 5z plus 15. So we're going to be able to substitute in this 5z plus 15 for x in one of the other equations. So I'm actually going to plug it into the second equation. So we're going to have -2x, I'm going to leave the parentheses for the x, plus 3y plus z equals -9. And our parentheses, we're going to fill in this 5z plus 15. So we're going to need to use a little bit of distribution to distribute this -2. Becomes -10z minus 30 plus 3y plus z equals -9. So I'm going to combine together my z's. So I have -10z and plus z. That gives me a -9z plus 3y minus 30 equals -9. So we have substituted that x into a different equation. Now I need to isolate a different variable. So isolate either the z or the y. So for this problem, I'm going to choose to isolate the y. You could isolate the z, but when we divide things by 9, we're going to end up working with some fractions. So like I said the other day, fractions are okay. Just makes it a little bit more tricky. So I'm going to add my 9z and my 30 to the other side. So I get 9z plus 30 minus 9 over on the right. And if we simplify that, it simplifies to 9z plus 21. So when I divide by 3, we find out that y equals 3z plus 7. So I have x equals 5z plus 15, y equals 3z plus 7. We're going to take both of those pieces and substitute them in. So now that we have our x and our y in terms of z, I'm going to bring down this original top equation that we haven't used yet, and we're going to replace our x and our y both with those other two equations. So 2x plus 5y minus 4z equals 23. And I'm going to fill in my x with 5z plus 15 from right here. And I'm going to fill in my y with 3z plus 7. Okay, so we're going to have to do a little bit of distributing to simplify this down and solve it. So I have 10z plus 30. Distribute this 5. So we have plus 15z plus 35. I still have a minus 4z, and that's all equal to 23. So that's all one expression or one equation right there. We need to combine together our z's. So 10z plus 15z is 25z, minus 4z is 21z. Then I have 30 and 35, so plus 65 equals 23. And then from here, we're going to subtract 65. So we get 21z equals, negative 42. Can't see that negative. So negative 42. And then when we divide by 21, we find out that z equals negative 2. Now that we have that one value, we're going to work backwards and plug it in for our y. So y equals 3 times negative 2 plus 7, y equals 1. And then we get to plug it in for our x as well. So x equals 5 times negative 2 plus 15, or x equals 5. So our ordered triple for this one is 5, 1, negative 2. Okay, our work is kind of all over the place, lots of arrows, things like that. I kind of expect that in here. Okay, normally in math, we like to see you work downward, but since there's so much substituting and stuff like that, your work on this kind of gets a little bit spread out. So that's okay. Just make sure to draw your arrows so that I know how to follow your work on your assignment.